everyone, in this video we will be solving system of equations using substitution method, and this is the second part. I will put the link of the first part in the description box below. Let's take this first example right here. We have some steps to follow in order that we can solve systems of equation using substitution method. The first step is to substitute or plug in one of the equations to the other equation and solve for the first variable. In order that we can better understand how substitution works in solving systems of equation, I have created cards here where I wrote these equations that we have there. Now notice that this first equation here, x is equal to y squared. And then the second equation, y equals to x minus 6. So substitution means we plug in. So what are we going to do is, since both of these are x's, now, what I would want to do is I will take this y squared off of there. And since that is equal to x, I will put this y squared into the second equation in replacement of the x, since this y squared is equal to x. So then I am going to put this y squared in there. And so this is what we mean by substitution. What I did was I took this y squared off of the first equation. I plugged it into the x of the second, since this y squared was equal to x. And this is how the equation is going to look like now. So then we can go ahead and write this as y. So this is again the first step. So that's going to be y is equal to y squared minus 6. So then we can go ahead and simplify this. So that we can go ahead and make one side equal to 0. So we can solve for y. So then we go ahead and subtract y from both sides minus y. So then we go ahead and equal this y minus y would be equal to 0. And that is equal to y squared minus y minus 6. Now, others are going to think that that's y squared minus y, so this should have been y. So these are not like terms, because this is a squared y and this is not a squared y. So we don't subtract them together. So they are different. They are unlike terms. So then from here, we are going to simplify this so that we can use the zero product property. We can factor these out using the box and diamond. So I'm going to show the box and diamond method right here. So we start with the diamond first. So what to write on the diamond would be the product of the last and the first. So that is negative 6y squared. And that is the middle term will go to the bottom of the diamond. That is negative y. So we need to determine the factors for this. The factors for this negative 6y squared and negative y would be negative 3y and 2y. So that if we multiply these two, negative 3y times 2y is negative 6y squared. Negative 3y plus 2y is negative y. So then we can go ahead and draw the box here, so the 2 by 2 box, so that we can find the factors. And that would be, the first term is y squared negative 6, and then the red factors shall be written in here. So that is, it can be in any of these two boxes here. So negative 3y and 2y. So then the factors that we can have here would be y and y. That's a positive 2 and negative 3. So these are the two factors. So then I'm just going to go ahead and rewrite this over here. So that is 0 is equal to, that's going to be y plus 2. And then that is y minus 3. So I wrote that over there. And so we are going to use the zero product property to solve for y. So then we go ahead and say y plus 2 equals 0. So we are going to subtract 2 from both sides, minus 2. So then our first y would be y is equal to negative 2. So this is our first value for y. The second value of y would come from this. So that is y minus 3 equals 0. So plus 3 and plus 3. So that means our second y is equal to 3. So these are the two values of y, and this is again our first step. Now we are ready to move on to the second step. So the second step is to solve for the second variable by plugging in the values from step 1 to any of the two original equations. I'm just going to label this as step 2 right here. So we are going to use any of the original equations that we have here to solve for the other variable. So we already have the y, so we're supposed to be solving for x. So we can use any of these. So since this one is already set up, again, you can use the second one. It doesn't really matter. But let's use this first equation right there. We let y is equal to -2. So we are going to determine what is the x value when y is -2. The trick in order that we can solve for the other variable is to change the variables into parentheses before we plug in values. So we're using this first equation right here. Again, you can use the second, it doesn't matter. So that would be y squared is equal to x. Again, we're solving for x, so change the variable. The variable that we have already is y, so I changed the y into parentheses squared, and that is equal to x. So then I put in the value since we say that our y was -2. So then we go ahead and simplify this. -2 squared would be a +4, and that is equal to x. This means that our first point of intersection would be at 4, and then our y value is -2. So this is our first point of intersection. Now to find the second point of intersection, I'm just going to show you the second equation right here just to make sure that it works for both of them. So we are done with y is equal to -2. So we let y is equal to 3, and we use this second equation right here. So y is equal to x minus 6, and we're solving for y. Again, the trick is to change the variable into a parentheses before we plug in values so we don't mess up with the math. So then we are going to change, since we already have the y, so I changed the y into parentheses is equal to x minus 6. So then we put in the 3 to the y. So then this would come out 3 is equal to x minus 6. We want to solve for x, so we are adding 6 from both sides plus 6. So then we go ahead and simplify this. Our x is equal to 9. And so our second point of intersection is that when x is 9, then our y is 3. So this is the second point of intersection. On the side, you will see the graph of these two equations that we have right here. And it can be seen that these two graphs are actually intersecting. That means they are touching each other at 4, -2 and 9, 3. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So I have prepared this cards right here. So this will help us visually see what's going on with the substitution method. So we have this first equation and this second equation. Now, what I'm going to do now is since I know that y is isolated by itself already, and that is equal to x minus 4, so I can take this x minus 4 off of there. And then since this x minus 4 is equal to y, I can go ahead and put this into y of the first equation. So I will plug that in there. And so that's what we mean by substitution. Substitution means we plug in. So what's going on here is that I took this off of the y. Since this is equal to y, I plugged it into the y. So then our equation came out to look like this. Now we are supposed to add a parenthesis to this because that means it's all purple color. That means they're all together x minus 4. So then we can go ahead and rewrite this equation using this one right here when we plugged it in. So this is step 1 right here. Substitute and plug in one of the equations to the other equations and solve for the first variable. So that's what we did. We plugged it in. So then we can go ahead and rewrite this as x minus 4. That's what I wrote in there. And then that's a squared plus 2 is equal to x. So what I did was I took the x minus 4 off of there and plugged it into the y. And that's how I got there. So then we can go ahead and use the area model to multiply this binomial. I'm going to show the work up here. And that's the one that we write here instead of x minus 4 squared. So that would come out x squared minus 8x plus 16 plus 2 equals x. So what I did was up to 16, but then we still have a plus 2, and then that is equal to x. So then we can go ahead and combine like terms. So we have the 16 and the 18 are the constants that we can combine. So then we can go ahead and rewrite this as x squared minus 8x plus 18 equals x. So that we can use the zero product property to solve for x. We can subtract x from both sides to make one side equal to 0. So that's minus x from both sides. So then we are left with x squared minus 9x plus 18 equals 0. And then from here, we can use the box and diamond to factor this out. So I'm going to show the box and diamond method on this side right here. So that would be x minus 6 and x minus 3 equals 0. So we use the zero product property to solve for x. So that would be x minus 6 equals 0 and x minus 3 equals 0. So then we are going to add 6 from both sides plus 6. So then we have our first value of x would be positive 6. So that's the first x. So the second x would be derived from here. So that's a plus 3 and plus 3. So then we go ahead and say that our x is equal to positive 3. And this is the second value of x. Now, what are we going to do next is to move on to the second step. Solve for the second variable by plugging in the values from step 1 to any of the two original equations. So then I can go ahead and divide this so we can show the second step. So we move on to the second step now. So I'm just going to label this as step 2 right here. So we're going to use the original equation. It doesn't matter which of these that you want to use, which of these is you're more comfortable with. So it doesn't really matter when you are doing step 2. So let's use this, since we're solving for y, let's use the second equation right here. So we let x is equal to 6. This is the first one that we solved. And then we are going to write the equation y equals x minus 4. Again, we're solving for the y because we already have the x. So then we can go ahead and change the x into a parenthesis. So that is y equals parenthesis minus 4. And so we put in the 6 here. So y is equal to 6 minus 4. Or our y is 2. So this is the value. So that means that the partners are actually, we have when x is 6, our y is 2. So this is our first point of intersection. Now to find the second point of intersection, we're going to use this one right here. So we let x is equal to 3. So we can use any of the equation here. So again, it doesn't matter which one you would want to use. So we use the second one. So y is equal to x minus 4. Our x was 3. So I changed the x into parentheses and plug in. So then the second point of intersection is that when x is 3, so when x is 3, the y is negative 1. And this is the second point of intersection. On the side, you will see the graph of these two equations that we have here, and it can be seen that these two graphs intersect at 0.62 and 3, -1. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!